We're going to go over the third problem. Once again, I encourage you, please do not write while you are watching the video. If you are copying, you will not learn the material. You can learn it much better if you try it after watching the video. The goal of this proof is to prove that CA is the same as CB. These two sides are the same. It looks like I have two separate triangles that I will try to prove are the same along the way. Then after that, I can say the pieces are the same because of CP/CTC. If there were an additional statement, if it were asking me to prove that something was bisected or that the triangle was isosceles, which we could do in this proof, I'll talk about that at the end, I would add that at the very end after I use CP/CTC to show that the pieces were the same. I'm going to begin the proof by writing my givens. The first thing here says that CD and this symbol, upside down T, means that it is perpendicular. It meets at a 90-degree angle with AB. So I'm going to see where CD touches AB. That happens at point D. There is a 90-degree angle on each side there. That can go in my proof as my first given. The next given is that D is in the middle, or it's the midpoint of A and B. Many students at this point will want to just mark that these two pieces are the same, but never include it in your proof. When you have given that a midpoint is in between, or I guess there is a midpoint on a line segment, you must follow that up by saying that the two pieces are the same. So if D is exactly in the middle of A and B, that means the two pieces that make up A and B are the same as each other. In this case, AD will be the same as DB because D is in the middle. So I can say AD congruent to DB by definition of midpoint. So far, I have a side and an angle. I am one step away from proving these triangles are congruent. These are sharing a side here, CD. I can add that as a reflective side, that CD is the same as CD. It is in both triangles and it is the same size in both. This is the reflexive property. At this point, I have that the two triangles are congruent. And if you're looking carefully, you'll see it as side, angle, side. Many students will consider that if there is a 90-degree angle, they should assume that it is hypotenuse leg. That is only the case if I have the one across from the 90, which is the hypotenuse marked. That is not the case here. The angle meets in between the two sides, so it is side, angle, side. I will put these in order. I have triangle. I can choose CBD goes with. From the triangle on the left, C goes with C, B goes with A, and D goes with D. From the side angle side, the first side I had marked that AD and DB were the same came in step 3. The angle I had marked, the perpendicular 90-degree angles, was from step 1. And then the fact that CD was the same as CD came from step 4. Now that I have proven that these two triangles are the same, I can say that any of their pieces that go together are the same. Namely, the ones that matter in this case are CA and CB, because that is what I'm being asked to prove. So I can say that CA goes with CB. You'll notice that CB are the first two here, CA are the first two here. They do go together, and since the triangles are the same, they should be the same as well. That is what CP/CTC means. I can mark it in the picture if I'm inclined. That is the end of the proof. I'd like to note right now that with these two sides here being congruent, if I were interested, I could say, or if I were asked to, I could say that the entire triangle here, triangle ACB, is isosceles because it has two sides that are the same. That would be by definition of isosceles. That is not requested by this proof, but if instead of this it said prove that triangle ACB is isosceles, I would have the exact same steps up until this point, and the only thing I would have to add is that triangle ACB is isosceles by the definition of isosceles. It has two sides that are the same. Side AC and side BC. And so because it has two sides that are the same, it must be isosceles. If you are ever trying to prove isosceles, that is all you have to do. We would prove the triangle's congruent, show the pieces are the same with CP, CTC, and then I can end with my statement by definition.